now we're going into, now that we know that the particles have energy and less energy in a solid than we have in a gas, and it all revolves around energy, and the energy is dependent on how much heat I've produced or I've transferred. We are going to talk about how does heat go from one thing to another. Okay, again, in the home, for winter, we'll talk about a lot about heat. You'll be doing and using a lot of heat, and there's 3 different ways that heat can be moved. Okay, so let's have a look at the first one, and this is called conduction. So there's 3 ways. So the first one, we've got conduction, and then the second one, convection, and then the next one is called radiation. So those are the 3 methods of energy transfer, and they occur in different substances, whether it's a solid and a liquid and a gas, and we'll go into each one and then explain the mechanism where the heat is transferred, and then hopefully we can answer some questions around it, and we can apply our knowledge on heat transfer based on everyday examples. Okay, so let's quickly go through conduction. So conduction happens when a solid gets warmer. So when heat is transferred through a solid and sometimes through a liquid. So let's quickly, but mostly through a solid. Let's quickly have a look. If we have a metal spoon, or we have something that's metal, and we're roasting marshmallows and we're putting it in a flame, and remember the flame, we said the flame is a source of energy and a source of heat. And remember what happens when particles get more energy? They start moving a bit more. Okay, so conduction, if we can zoom into this metal rod, remember it's a solid, so we know that the particles will be closer together. So I'm going to, instead of just little dots, we'll put little circles. So these particles are there. They're not moving a lot. Just remember, they're in a solid and they don't have a lot of energy. And then, when we put it in a flame and we hold it onto this end, okay, my wonderful drawing of my fingers, oh, that's ugly. If we hold it on like that, there you go, what's going to happen is the energy from the flame is going to get transferred. And I don't know if you, I'm talking out of experience, if you hold onto a metal rod and you put it in a flame, after a while you'll burn your hand. So how did the energy from the flame get into your hand? Okay, so let's have a look. So that particle there, these particles that's closest to the flame will get energy. So remember, they now just huddled and they're vibrating like this. So if this gets energy, the energy gets moved into these particles. And then when this particle gets hot, it has a lot of energy. What happens is it starts moving a bit faster, and because it moves quite a bit faster, it doesn't really have a lot of room to move, it's bumping into the others. And as it's bumping into the atom next to it, the particle next to it, what's going to happen is it is transferring its energy into the next particle. And then that particle starts moving and it's bumping into the other, and it gets transferred into this one. So over some time, the energy will be transferred in the form of heat from these particles at the very end all the way down into your hand. Okay, so this is called a conduction. When energy gets travels through a solid all the way through until it reaches your hand. Okay, so we have different things that transfer energy in different ways. So if you think of a metal, if you have like a metal spoon compared to a plastic spoon and you put that in hot water, the metal spoon will get hotter faster. And why is that? So if we zoom into those particles, plastic and metal, the metal particles take energy and they pass it on easier than in a plastic spoon. This plastic spoon needs heaps of energy for those particles to actually start moving and bump into the others so it gets transferred. So we call those ones that's very lazy and it's really hard to move energy through insulators, and then things that are really easy to move energy through are called conductors. So we've got an insulator that doesn't do a lot, that doesn't transfer the energy a lot, and we have conductors that are really easy to transfer heat.